The National Electrical Code, Section 404.9 addresses the minimum height for receptacles installed in dwelling units. According to this section, a receptacle shall not be placed less than 150 mm or 6 inches above the floor. It's important to note that the NEC does not have an explicit maximum height requirement for receptacles. The maximum height is typically dictated by personal preference and aesthetic considerations within a practical range. The typical installation height for receptacles is 18 inches above finished floor. This height is common because it allows for easy access while sitting or standing. In some cases, receptacles may be installed at 12 inches above finished floor, particularly in basements or other areas where furniture may obstruct access to receptacles at the standard 18-inch height. Occasionally, a height of 4 feet above finished floor may be used for special applications, such as for ceiling-mounted televisions or high-mounted wall art. When determining the appropriate receptacle height, several factors should be taken into consideration. Firstly, accessibility is important. Receptacles should be placed at a height that is convenient for the intended use, making it easy for occupants to plug in and unplug devices. Secondly, the placement of furniture should be considered. It's important to avoid placing receptacles behind or underneath furniture that may obstruct access to them. Thirdly, safety is a key concern. Receptacles should be installed high enough to prevent electrical cords from becoming a tripping hazard. Finally, it's essential to be aware that local building codes may have additional requirements or recommendations regarding receptacle height, so it's important to check local regulations. In summary, while the NEC specifies a minimum height of 6 inches for receptacles in dwelling units, there is no explicit maximum height. The typical installation height is 18 inches, but this may vary depending on the specific circumstances and considerations such as accessibility, furniture placement, and safety. It's crucial to consult local building codes to ensure compliance with all applicable regulations. In addition to the minimum height requirements, it's essential to understand the general requirements for receptacle placement in dwelling units as outlined in the National Electrical Code. Section 210.52 covers general provisions for dwelling unit receptacle outlets. This section mandates that receptacle outlets be installed in every kitchen, family room, dining room, living room, parlor, library, den, sunroom, bedroom, recreation room, or similar room or area. The spacing of these receptacles is also crucial. Wall space is measured horizontally along the floor line, and receptacle outlets must be installed so that no point along the wall line is more than 6 feet, or 1.8 meters, measured horizontally, from an outlet inlet space. This ensures that extension cords are not used as a substitute for permanent wiring. The intent is to provide convenient access to electrical power throughout the dwelling unit. Wall space includes any space 2 feet or more in width and unbroken along the floor lined by doorways, fireplaces, and similar openings. Fixed cabinets that do not extend to the ceiling or floor also constitute wall space. Section 210.52c provides specific requirements for countertop receptacles in kitchens and dining areas. Countertop spaces 12 inches or wider must have a receptacle outlet. No point along the countertop wall line should be more than 24 inches, or 600 millimeters, measured horizontally, from a receptacle outlet. This ensures easy access to power for kitchen appliances and other countertop devices. At least one receptacle outlet must be provided for each island countertop space with a lawn dimension of 24 inches, or 600 millimeters, or greater, and at least one receptacle outlet must be provided for each peninsular countertop space with a lawn dimension of 12 inches, or 300 millimeters, or greater. These receptacles must be located within the countertop or within 12 inches below the countertop. These rules aim to prevent lawn extension cord runs across countertops, which can pose safety hazards. Bathrooms have specific receptacle requirements outlined in Section 210.52d. At least one receptacle outlet must be located within 36 inches, or 900 millimeters, of the outside edge of each basin. The receptacle outlet must be located on a wall or partition that is adjacent to the basin countertop or basin. This receptacle is intended for use with small appliances such as hair dryers and electric shavers. All 125-volt, 15 or 20 amp receptacles in bathrooms must be ground fault circuit interrupter protected. This requirement is designed to protect against electrical shock in wet environments. Outdoor outlets also have specific requirements. Section 210.52e requires at least one receptacle outlet to be accessible at an outdoor location for each dwelling unit that has direct access to the outdoors. This receptacle must be installed at the front and back of the dwelling. These outdoor receptacles are intended for use with power tools, lighting, and other outdoor equipment. All outdoor receptacles must have weatherproof protection. This protection can be in the form of a weatherproof enclosure or a weather-resistant receptacle. Garages and accessory buildings also have receptacle requirements. Section 210.52g requires at least one receptacle outlet in each attached garage and each detached garage or accessory building with electric power. These receptacles are intended for use with power tools, lighting, and other garage or workshop equipment. Basements must also have at least one receptacle outlet as per section 210.52h. This receptacle is intended for use with laundry equipment, freezers, and other basement appliances. Hallways are addressed in section 210.52i, which requires that hallways of 10 feet or more in length have at least one receptacle outlet. This receptacle is intended for general use and to reduce the need for extension cords in long hallways. In addition to the location and spacing requirements, there are also requirements for the type of receptacles that can be used in certain locations. As mentioned earlier, bathroom receptacles must be ground fault circuit interrupter protected. Receptacles located in damp or wet locations must be listed for use in those locations. Tamper-resistant receptacles are required in dwelling units in areas where small children are likely to be present. This helps to prevent children from inserting objects into the receptacle and receiving an electrical shock. The National Electrical Code also addresses the height of switches. While there is no specific code section that mandates a precise height for switches, it is generally recommended that switches be installed between 44 and 48 inches above finished floor. This height is considered accessible for most individuals, including those with disabilities. The Americans with Disabilities Act (ADA) provides guidelines for the accessible design of buildings and facilities. These guidelines recommend that switches and other operable parts be located no more than 48 inches above finished floor for a side reach and no more than 44 inches above finished floor for a forward reach. While the ADA guidelines are not mandatory for all residential construction, they are often used as a best practice for ensuring accessibility. In addition to the height of receptacles and switches, it's important to consider the wiring methods used for electrical installations. The National Electrical Code provides detailed requirements for wiring methods, including the type of cable or conduit that can be used, the size of conductors, and the methods for supporting and securing the wiring. Common wiring methods used in residential construction include non-metallic sheathed cable, often referred to as NM cable or Romex, and electrical metallic tubing, often referred to as ENT conduit. NM cable is a flexible cable that contains two or more insulated conductors and a grounding conductor. It is commonly used for branch circuits in residential buildings. EMT conduit is a rigid metal conduit that is used to protect conductors from physical damage. It is often used in commercial and industrial buildings, but can also be used in residential buildings in certain applications. The size of conductors used for electrical wiring is determined by the ampacity of the circuit. Ampacity is the maximum amount of current that a conductor can carry without exceeding its temperature rating. The National Electrical Code provides tables that specify the ampacity of different sizes of conductors. For example, a 14 American wire gauge copper conductor with type TW insulation has an ampacity of 15 amps, while a 12 American wire gauge copper conductor with type TW insulation has an ampacity of 20 amps. The grounding system is a critical part of any electrical installation. The grounding system provides a path for fault current to flow back to the source, which helps to trip a circuit breaker or fuse and prevent electrical shock. The National Electrical Code requires that all electrical equipment be grounded. This includes receptacles, switches, lighting fixtures, and appliances. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, a grounding conductor, and a bonding conductor. The grounding electrode is connected to the earth, providing a low impedance path for fault current to flow to ground. The grounding conductor connects the grounding electrode to the service equipment, such as the main panel board. The bonding conductor connects the service equipment to the metal enclosures of electrical equipment, such as receptacles and lighting fixtures. In addition to the grounding system, ground fault circuit interrupters, or GFCIs, provide additional protection against electrical shock. A ground fault circuit interrupter is a device that monitors the current flowing in a circuit and detects any imbalance between the hot conductor and the neutral conductor. If a ground fault, such as a person touching a live wire, occurs, the ground fault circuit interrupter will quickly trip the circuit and stop the flow of current. Ground fault circuit interrupters are required in bathrooms, kitchens, outdoor locations, and other areas where there is a risk of electrical shock. Arc fault circuit interrupters, or RFCIs, provide protection against electrical fires. An arc fault circuit interrupter is a device that monitors the current flowing in a circuit and detects any abnormal arcing. Arcing can occur when there is a loose connection, damaged insulation, or other fault in the wiring. If an arc fault occurs, the arc fault circuit interrupter will quickly trip the circuit and stop the flow of current, preventing a fire from starting. Arc fault circuit interrupters are required for branch circuits that supply power to dwelling unit living areas, such as bedrooms, living rooms, and family rooms. The National Electrical Code is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect the latest advances in technology and safety practices. It is important for electricians and other electrical professionals to stay up to date on the latest edition of the National Electrical Code to ensure that their installations are safe and compliant. In addition to the National Electrical Code, there may be local electrical codes and regulations that must be followed. These local codes may be more stringent than the National Electrical Code in some areas. It is important to check with the local building department to determine the specific electrical code requirements for a particular project. Electrical work can be dangerous. It is important to take precautions to protect yourself from electrical shock and other hazards. Always turn off the power before working on electrical equipment. Use insulated tools and wear appropriate personal protective equipment such as rubber gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to do the work. When working with electrical wiring, it is important to identify the different conductors. The hot conductor is typically black or red, the neutral conductor is typically white, and the grounding conductor is typically green or bare copper. The hot conductor carries the current from the source to the load. The neutral conductor provides a return path for the current. The grounding conductor provides a path for fault current to flow back to the source. It is important to never connect the hot conductor to the neutral conductor or the grounding conductor. This can cause a short circuit and create a fire hazard. When making connections, use appropriate wire connectors. Wire connectors are designed to provide a secure and reliable connection between two or more conductors. There are many different types of wire connectors available, so it is important to choose the right connector for the application. When splicing wires, make sure that the insulation is stripped back far enough to allow for a good connection, but not so far that the bare wire is exposed. Wrap electrical tape around the splice to insulate it and protect it from moisture. When installing receptacles and switches, make sure that they are securely mounted to the wall box. Use the screws provided with the receptacle or switch to attach it to the box. Do not over-tighten the screws, as this can damage the receptacle or switch. When installing lighting fixtures, make sure that they are properly supported. Use the appropriate mounting hardware for the type of fixture and the type of ceiling or wall. Do not exceed the maximum wattage rating for the fixture. When installing appliances, follow the manufacturer's instructions carefully. Make sure that the appliance is properly grounded and that the power cord is in good condition. Do not overload circuits. Each circuit is designed to carry a certain amount of current. If you overload a circuit, the circuit breaker may trip or the fuse may blow. This can be a nuisance, and it can also be a fire hazard. To avoid overloading circuits, distribute the load evenly among the different circuits in your home. If you are not sure how to do this, consult with a qualified electrician. If you have any questions or concerns about electrical safety, consult with a qualified electrician. Electrical work can be dangerous, so it is important to take precautions to protect yourself and your family. Remember to always prioritize safety when working with electricity.